Hi, hello, this is Giri, teaching 10th Mathematics, the chapter Coordinate Geometry. Questions and solutions from world public papers. Here is the first question. Find the coordinates of points of trisection of the line segment joining point A 4 minus 1 and B minus 2 minus 3. I shall repeat. Find the coordinates of the points of trisection of line segment joining point A 4 minus 1 and B minus 2 minus 3. This question is appeared in June 2015 and March 2017. Here is the diagram. Here total AB is the line segment. A to B is line segment. The coordinates of A 4 minus 1 and the coordinates of B minus 2 minus 3. Now we have to divide this total line segment into three parts. Trisection means I have to divide the total line segment into three equal parts. Now in order to divide it into three equal parts, you have to cut the line segment at 2 points. One point is C and the second point is D. Now since this AB is divided into three equal parts, the length of AC is 1 unit, the length of CD is 1 unit and the length of DB is also 1 unit. The point C is at a distance of 1 unit from A and at a distance of 1 plus 1 2 units from B. Therefore, C divide the line segment AB in the ratio 1:2. And the point D is at a distance of 1 plus 1 2 units from point A and 1 unit from B. Therefore, D divide the line segment AB in the ratio 2:1. Now here is the solution. The points of trisection C, D divide the line segment joining AB internal in the ratio 1:2, that is C point, and D point is 2:1 respectively. Now let us write the formula for internal division. Internal division is equal to m1 x2 plus m2 x1 by m1 plus m2. m1 x2 plus m2 x1 by m1 plus m2. m1 y2 plus m2 y1 by m1 plus m2. Here the coordinates of A will be x1 y1, 4 minus 1. x1 is 4 and y1 is minus 1. The coordinates of B minus 2 minus 3. Minus 2 is x2 and minus 3 is y2. Now in order to find out the first point C, as you know that C divide AB in the ratio 1:2, m1 is 1 and m2 is 2. Now let us substitute these values in the given formula. C is equal to m1 x2. m1 is 1 into x2 is minus 2, 1 into minus 2, plus m2 into x1. m2 is 2 into x1 is 4, 2 into 4 by m1 plus m2, 1 plus 2. Similarly, the coordinates of y, m1 y2, m1 is 1 into y2 is minus 3, 1 into minus 3, plus m2 y1, m2 is 2 into y1 is minus 1, 2 into minus 1 by m1 plus m2 is again 1 plus 2. Now let us simplify this. 1 into minus 2 is minus 2 and 2 fours is 8. 1 into minus 3 is minus 3 and 2 into minus 1 is minus 2 by 1 plus 2 is 3. Here also 1 plus 2 is 3. Now 8 minus 2 is 6 by 3. 6 by 3 is 2. And minus 3 minus 2 is minus 5 by 3. Therefore, one point of trisection is 2 minus 5 by 3. Now let us find out the coordinates of D. In order to find out the coordinates of D, again these are the points A and B, and now D may divide AB in the ratio 2:1. Therefore m1 is 2 and m2 is 1. D is equal to, again use the same formula, m1 x2 plus m2 x1 by m1 plus m2, m1 y2 plus m2 y1 by m1 plus m2. Now substitute the values. m1 x2, m1 is 2 into x2 is minus 2, 2 into minus 2, plus m2 x1, 1 into 4, x1 is 4, 1 into 4 by m1 plus m2, 2 plus 1, comma, the coordinates of y, m1 y2, 2 into minus 3, 2 into minus 3, plus m2 y1, m2 is 1 and y1 is minus 1, 1 into minus 1 by m1 plus m2 is 2 plus 1. Now let us simplify this. 2 into minus 2 is minus 4, 1 into 4 is plus 4, by 2 plus 1 is 3. 2 into minus 3 is minus 6. Plus 1 into minus 1 is minus 1 by 2 plus 1 is 3. Minus 4 plus 4 is 0 by 3. Minus 6 minus 1 is minus 7 by 3. 0 by 3 is 0 and this is minus 7 by 3. Therefore, the coordinates of the trisection of the line segment joining are 2 minus 5 by 3 and 0 minus 7 by 3. Another question. Prove that the points minus 7 minus 3, 5 10, 15 8 and 3 minus 5 are the vertices of a parallelogram. I shall repeat. Prove that the points minus 7 minus 3, 5 10, 15 8, 3 minus 5 are the vertices of a parallelogram. This question is appeared in March 2018. Parallelogram means it is a quadrilateral having 4 sides, and the main property is their opposite sides are equal and opposite sides are parallel. Now, in order to prove that a quadrilateral is a parallelogram, it is enough that if you can prove that the diagonals bisect each other. Look at this parallelogram. ABCD is the parallelogram in which one diagonal is AC and the second diagonal is BD. Now let us prove that AC and BD may bisect at point E. Bisection means into 2 equal parts. Now we have to prove that E is the midpoint of AC and again E is the midpoint of DB. You see, here is the solution. The formula to find the midpoint of the diagonal AC is x1 plus x2 by 2 and y1 plus y2 by 2. The coordinates of A minus 7 minus 3 and the coordinates of C 15 8. Coordinates of A are x1 y1 and coordinates of C will be x2 by 2. x1 plus x2 by 2 minus 7 plus 15 by 2. y1 plus y2 by 2 minus 3 plus 8 by 2. 15 minus 7 is 8 by 2 and 8 minus 3 is 5 by 2. 2 in 8 4 times. Therefore, the midpoint of the first diagonal AC is 4 5 by 2. The midpoint of the diagonal of the BD is again the same formula, x1 plus x2 by 2 and y1 plus y2 by 2. Here the coordinates of B 5 10 and the coordinates of D 3 minus 5. 5 10 and 3 minus 5. Now x1 plus x2 means 5 plus 3 by 2. 5 plus 3 by 2. y1 plus y2 by 2. 10 minus 5 by 2. 5 plus 3 is 8 by 2 and 10 minus 5 is 5 by 2. 2 in 8 again 4 times and this is 5 by 2. Now you see from these two, the midpoint of the first diagonal AC is 4 5 by 2 and the midpoint of the second diagonal BD is also 4 5 by 2. Therefore, the midpoint of the diagonal AC is equal to the midpoint of the diagonal BD. Since the midpoints are same, the diagonals are bisecting each other. Since these diagonals bisect each other, the given quadrilateral is a parallelogram. Another question. Find the coordinates of points which divide the line segment joining A minus 4 0 and B 0 6 into 4 equal parts. I shall repeat. Find the coordinates of points which divide the line segment joining A minus 4 0 and B 0 6 into 4 equal parts. This question is appeared in June 2018. Here is the diagram. AB is the line segment. A to B is the line segment. Now this line segment is to be divided into how many parts? Ready students, you may please verify the question. Now into how many parts this line segment AB is to be divided? Yes, it is to be divided into 4 equal parts. Means this total AB is to be divided into 4 equal parts. In order to divide it into 4 parts, we have to cut it at 3 places. One is C, second is D and third is E. Since it is divided into 4 equal parts, each is equal to 1 unit, 1 unit, 1 unit and 1 unit. Okay. Now if we verify this, it is very clear that D is the midpoint of AB. D is the midpoint of AB. And C is the midpoint of AD. And E is the midpoint of DB. Now let us find the solution. Here the points C, D and E divide the total line segment into 4 equal parts. Now if you can observe very clear that D is the midpoint of AB and C is the midpoint of AD and E is the midpoint of DB. Now let us find the midpoint of AB first. If you find the midpoint of AB, then you will get D. Now the coordinates of A minus 4 0 and the coordinates of B 0 6. D is the midpoint. Midpoint formula x1 plus x2 by 2, y1 plus y2 by 2. x1 plus x2 minus 4 plus 0 by 2. y1 plus y2 0 plus 6 by 2. Minus 4 plus 0 is minus 4 by 2, which is equal to minus 2. 0 plus 6 is 6 by 2, which is equal to 3. That is, we get the coordinates of D. Now let us find the coordinates of C. The coordinates of C, how can we get the coordinates of C? Look at the diagram. Good. C is the midpoint of AD. Now we have the coordinates of A 4 minus 4 0 and just we get the coordinates of D minus 2 3. Therefore you can take the coordinates of A as x1 y1 and the coordinates of D x2 y2. Now the coordinates of C is equal to x1 plus x2 by 2, y1 plus y2 by 2. Minus 4 minus 2 by 2, 0 plus 3 by 2. Minus 4 minus 2 is minus 6 by 2 and 0 plus 3 is 3 by 2. 2 in minus 6 minus 3 times and this is 3 by 2. Minus 3 and 3 by 2 are the coordinates of C. Now one more point is left, that is E. And how can you get E? Yes, if you look at the diagram, E is the midpoint of DB. Now write the coordinates of D. We have the coordinates of D minus 2 3. Minus 2 3. And we know the coordinates of B 0 6. Then midpoint is x1 plus x2 by 2, y1 plus y2 by 2. Minus 2 plus 0 by 2 and 3 plus 6 by 2. Minus 2 plus 0 is minus 2 by 2 and 3 plus 6 is 9 by 2. 2 in minus 2 minus 1 times and this is 9 by 2. Therefore, the required points are C minus 3 3 by 2, D minus 2 minus 3 and E minus 1 9 by 2. Now another question. If the points 1, 2, 4, y, x, 6 and 3, 5 are the vertices of a parallelogram taken in order, then find the values of x and y. I shall repeat. If the points 1, 2, 4, y, x, 6 and 3, 5 are the vertices of a parallelogram taken in order, then find the values of x and y. This question is appeared in public June 2016 and March 2018. Here, in order to find out this, first of all, these are the vertices of the parallelogram. Look at the diagram. ABCD is a parallelogram. First point is A and this is B, this is C and this is D. Since these are the vertices of a parallelogram, we know that in any parallelogram the diagonals bisect each other. Since the diagonals are bisecting each other, let us find the midpoint of the first diagonal AC and let us find the midpoint of the second diagonal BD. They are intersecting at point E. This E should be the midpoint of AC and BD. Therefore, first of all, let us find the midpoint of the diagonal AC. Coordinates of A 1 2 and coordinates of C x 6. Midpoint formula x1 plus x2 by 2, y1 plus y2 by 2. x1 plus x2 means 1 plus x by 2. y1 plus y2 by 2. 2 plus 6 by 2. 1 plus x is 1 plus x only. 1 plus x by 2. 2 plus 6 is 8 by 2. This 2 in 8 4 times. This is the midpoint of the first diagonal AC. Now let us find the midpoint of the second diagonal. What is the second diagonal from the given diagram? Good. The second diagonal is BD. Therefore, the midpoint of BD is again x1 plus x2 by 2 and y1 plus y2 by 2. The coordinates of B means second point 4y and the coordinates of D means fourth point 3 5. Now x1 plus x2 by 2, 4 plus 3 by 2. y1 plus y2 by 2, y plus 5 by 2. 4 plus 3 is 7 by 2 and y plus 5 by 2 is y plus 5 by 2. This is the midpoint of the second diagonal BD. Now it is given that these are the vertices of a parallelogram. Since ABCD is a parallelogram, the diagonals bisect each other. Since ABCD is a parallelogram, the diagonals should bisect each other. Diagonals are bisecting each other means the midpoint of the first diagonal AC is equal to the midpoint of the second diagonal BD. Now what is the midpoint of AC? Midpoint of AC is 1 plus x by 2 and 4 is equal to midpoint of BD is 7 by 2 and y plus 5 by 2. Now we got that 2 points are equal. If 2 points are equal, then their x coordinates are equal and their y coordinates are also equal. Now let us equate the x coordinates. 1 plus x by 2 is 7 by 2. 1 plus x by 2 is 7 by 2. You cancel by 2 and by 2. Then 1 plus x is equal to 7 and x is equal to 7 plus 1 other side minus 1 and 7 minus 1 is 6. And on the other side, if we equate the y coordinates, 4 is equal to y plus 5 by 2 or y plus 5 by 2 is equal to 4 or y plus 5 is equal to this 2 other side, 2 into 4 is 8 and y is equal to 8 plus 5 second side is minus 5 and 8 minus 5 is 3. Therefore, the x value is 6 and y value is equal to 3. Another question. Find the area of the triangle formed by 2, 3, minus 1, 3 and 2, minus 1 using Heron's formula. I shall repeat the question. Find the area of the triangle formed by the points 2, 3, minus 1, 3 and 2, minus 1 using Heron's formula. Now, do you know what is Heron's formula? Yes. There are two methods to find the area of a triangle in geometry. The first one is the formula of BH, of into base into height, if you know the base and height. And the second formula is Heron's formula, which is root over s into s minus a into s minus b into s minus c. Here a, b, c are sides, the lengths of the sides of the triangle, and s is half of the perimeter or semi-perimeter. Here let us write the triangle vertices first. Given the vertices of the triangle, a is equal to 2, 3 and b is equal to minus 1, 3 and c is equal to 2, minus 1. Here is the triangle ABC. Now in order to find out this area, first of all let us find the lengths of the sides. Let us find the length of AB, let us find the length of BC and the length of CA also. The length of AB means it is nothing but the distance between the two vertices AB. Therefore, in order to find out this side AB, you have to find the distance between AB and also find the distance between CD and let us find the distance between CA also, so that you will get all the three sides. You see here, the distance between AB, the formula to find the distance between a line segment x1, y1 and x2, y2 is root over x2 minus x1 whole square plus y2 minus y1 whole square. This is equal to, here x1, y1 are the coordinates of A and x2, y2 are the coordinates of B. x2 minus x1 whole square, x2 minus x1, x2 is minus 1, minus x1 is minus 2, minus 1 minus 2 whole square plus y2 minus y1 whole square. y2 is 3 and y1 is 3. y2 minus y1 means 3 minus 3 whole square. Minus 1 minus 2 is minus 3 whole square and 3 minus 3 is 0 square. Minus 3 whole square is minus 3 into minus 3, which is plus 9 plus 0 root over 9, that is equal to 3 units. Now find the distance between BC is root over x2 minus x1 whole square plus y2 minus y1 whole square. Now the coordinates of B x1 y1 and the coordinates of C will be x2 y2. B x1 y1 and C x2 y2. Now x2 minus x1, 2 minus of minus 1, 2 minus of minus 1 whole square plus y2 minus y1 whole square, minus 1 minus 3 whole square, minus 1 minus 3 whole square. This is 2 minus of minus 1 is plus 1, 2 plus 1 is 3 square plus minus 1 minus 3 is minus 4 square. 3 square is 9. Minus 4 whole square means minus 4 into minus 4 is plus 16. 9 plus 16 is root 25. Root over 25 is 5 units. Now CA. CA means the distance between C and A. The same formula, root over x2 minus x1 whole square plus y2 minus y1 whole square. Now the coordinates of C will be x1 y1 and the coordinates of A will be x2 y2. Coordinates of C x1 y1, coordinates of A x2 y2. Now x2 minus x1 whole square, x2 minus x1 whole square. x2 is 2 and x1 is 2, therefore it is 2 minus 2 whole square, 2 minus 2 whole square, plus y2 minus y1 whole square. y2 is 3 and y1 is minus 1. y2 means 3 minus y1 minus of minus 1 whole square. 2 minus 2 is 0 square, 3 minus of minus 1 is plus 1, 3 plus 1 whole square is 4 square. 0 square is 0 and 4 square is 16 and root over 0 plus 16 is 16, root over 16 is equal to 4. Now we got all the three sides of the triangle. Then let us find the semi-perimeter first of all. The semi-perimeter given by this letter S, which is equal to A plus B plus C by 2. Sum of the three sides, 3 plus 5 plus 4 by 2. What is 3 plus 5 plus 4? 3 plus 5 is 8, 8 plus 4 is 12 by 2, which is equal to 6 units. This is semi-perimeter S. Then formula to find area of the triangle using Heron's formula is root over S into S minus A into S minus B into S minus C is root over S is equal to 6 into S minus A is 6 minus 3 into S minus B is 6 minus 5 into S minus C is 6 minus 4. This is root over 6 minus 3 is 3 and 6 minus 5 is 1 and 6 minus 4 is 2. This is equal to root over 6 into 3 into 2 into 1 is 6. 6 into 6 is 36. Root over 36 is 6 square units. This is the area of the triangle using Heron's method. Another question. Show that the points minus 4, minus 7, minus 1, 2, 8, 5 and 5 minus 4 taken in order are the vertices of a rhombus and also find its area. I shall repeat. Show that the points minus 4, minus 7, minus 1, 2, 8, 5, 5 minus 4 taken in order are the vertices of a rhombus and also find its area. This question is appeared in June 2015 and March 2018. Here is the solution. Do you know what is a rhombus? Rhombus is also a quadrilateral in which all the four sides are equal. In any quadrilateral, if all the four sides are equal, then it is called rhombus. Then what is the difference between rhombus and square? Yes, in rhombus only four sides are equal, whereas the diagonals are not equal and the angle need not be 90 degrees. But whereas in square, all four sides are equal and each angle is equal 90 degrees and the diagonals are also equal in square. Therefore, every square is a rhombus, but every rhombus need not be a square. Okay, anyhow, let us consider the given four vertices as A, B, C and D. The given vertices of the rhombus are A minus 4 minus 7, B minus 1 2 and C 8 5 and D 5 minus 4. Now in order to prove it is a rhombus, let us prove that all the four sides are equal. Four sides means AB is first side, BC is the second side, CD is the third side and DA is the fourth side. First of all, let us find the side AB, which is nothing but the distance between the vertices A and B. Root over x2 minus x1 whole square plus y2 minus y1 whole square. x2 minus x1 minus 1 minus of minus 4 whole square, y2 minus y1 2 minus of minus 7 whole square. This is minus 1 minus of minus 4 is plus 4, 4 minus 1 is 3 square, and this is plus 7 and 2 plus 7 is 9 square. 3 square is 9, 9 square is 81, root over 9 plus 81 is root over 90 units. This is the length of AB. And next the length of BC. The length of BC means the coordinates of B will be x1, y1 and the coordinates of C x2, y2. Now x2 minus x1 whole square plus y2 minus y1 whole square. 8 minus of minus 1 whole square plus y2 minus y1 whole square 5 minus 2 whole square. This is equal to root over 8 minus of minus 1 is plus 1, 8 plus 1 is 9 square plus 5 minus 2 is 3 square. 9 square is 81 and 3 square is 9. 81 plus 9 is root over 90. Next, the length of CD. CD, distance. Again the same formula, x2 minus x1 whole square plus y2 minus y1 whole square. The coordinates of C will be x1, y1 and the coordinates of D x2, y2. Now x2 minus x1 whole square, that is 5 minus 8 whole square, 5 minus 8 whole square plus y2 minus y1 whole square means minus 4 minus 5 whole square. 5 minus 8 is minus 3 whole square, minus 4 minus 5 is minus 9 whole square, minus 3 whole square is plus 9, minus 9 whole square is plus 81, 9 plus 81 is again root over 90. Next, DA. In order to find the length of the side DA, the coordinates of D will be x1, y1 and the coordinates of A will be x2, y2. Then distance formula, root over x2 minus x1 whole square plus y2 minus y1 whole square is equal to x2 minus x1 minus 4 minus 5 whole square plus y2 minus y1 whole square minus 7 minus of minus 4 whole square. Minus 4 minus 5 is minus 9 whole square, minus 7 minus of minus 4 is plus 4, minus 7 plus 4 is minus 3 whole square. Minus 9 whole square is minus 9 into minus 9 is plus 81, minus 3 whole square is minus 3 into minus 3 is plus 9, root over 81 plus 9 is root over 90. If you observe all the four sides, the lengths of the four sides are equal. Root 90 units, root 90 units, root 90 units and root 90 units. Since AB is equal to BC is equal to CD is equal to DA, all four sides are equal, then ABCD is a rhombus. Then we proved the first part of the given question. Now the second part is you have to find its area of the rhombus. What is the formula to find area of a rhombus? Area of the rhombus is given by half of D1 D2. Half of D1 D2. What for D1 stands for? D1 stands for the first diagonal, the length of the first diagonal, and D2 stands for the length of the second diagonal. Therefore, you have to find the lengths of the diagonals also. These are the four sides. Then the length of each side is equal to root 90 units. And now, let us find the length of the first diagonal AC. AC is the diagonal. Again, length of the diagonal, distance formula, and we are finding the distance between A and C. Since AC distance we are finding, the coordinates of A will be x1, y1 and the coordinates of C x2, y2. x1, y1 and x2, y2. Distance formula, root over x2 minus x1 whole square plus y2 minus y1 whole square. x2 minus x1, 8 minus of minus 4 whole square plus y2 minus y1 whole square, 5 minus of minus 7 whole square. This is 8 minus of minus 4 is plus 4, 8 plus 4 is 12 whole square, 5 minus of minus 7 is plus 7, 5 plus 7 is 12 whole square. 12 square is 144 plus this is again 144, this is 2 into 144. Root over 144 is 12 root 2 units. This is the length of the diagonal AC. And let us find the length of the second diagonal BD. In order to find the length of the diagonal BD, the coordinates of B x1, y1 and the coordinates of D will be x2, y2. Coordinates of B minus 1, 2, x1, y1 and the coordinates of D 5 minus 4 will be x2, y2. Then the distance between BD is root over x2 minus x1 whole square plus y2 minus y1 whole square is equal to root over x2 minus x1, 5 minus of minus 1 whole square plus y2 minus y1 whole square minus 4 minus 2 whole square. 5 minus of minus 1 is plus 1, 5 plus 1 is 6 whole square, minus 4 minus 2 is minus 6 whole square. 6 whole square is 36, minus 6 whole square is also plus 36. 36 plus 36 is 2 times of 36, root over 36 is 6 root 2 units. Now we got the length of the first diagonal 12 root 2 units and we got the length of second diagonal 6 root 2 units. then area of the rhombus is half d1 d2. Half of d1 is 12 root 2 and d2 is 6 root 2. This is, here if you simplify this 2 in 12 6 times, therefore this is 6 root 2 into 6 root 2, 6 into 6 is 36, root over 2 into 2 is root over 4. This is 36 into root 4, square root of 4 is 2, 36 2s is 72 square units. This is the area of the rhombus. Another question. In what ratio does the points minus 4, 6 divide the line segment joining the points A minus 6, 10 and B 3 minus 8? I shall repeat. In what ratio does the points minus 4, 6 divide the line segment joining the points A minus 6, 10 and B 3 minus 8? This question is appeared in June 2016 and March 2019. Here is the solution. Here we are given a point minus 4, 6. This minus 4, 6 is dividing the line segment of AB. We got the coordinates of A and B also. Coordinates of A minus 6, 10 and the coordinates of B 3 minus 8. Now the point which divides this line segment AB is minus 4, 6. Let the point minus 4, 6 divide the line segment joining minus 6, 10 and 3 minus 8 in the ratio m1 is to m2. We have to find this ratio. Look at the question. In what ratio does the point minus 4, 6 divide these 2 points? Therefore, you have to find the ratio in which minus 4, 6 divide this line segment joining. Therefore, let us assume that the ratio in which minus 4, 6 divide AB is m1 is to m2. Now we know the formula to find internal division. Internal division is m1 x2 plus m2 x1 by m1 plus m2, m1 y2 plus m2 y1 by m1 plus m2. The formula to find internal division is m1 x2 plus m2 x1 by m1 plus m2, m1 y2 plus m2 y1 by m1 plus m2. Here the coordinates of A minus 6, 10 x1 y1, the coordinates of B 3 minus 8 x2 y2, and the ratio in which AB is divided is m1 is to m2. Now the point that divide A and B is minus 4, 6. Now let us substitute the values in the given formula. m1 and m2 are unknowns, therefore write them as it is m1 and m2 only. And substitute x1 y1 and x2 y2. x1 y1 minus 6, 10, x2 y2 3 minus 8. Now this point is divided by this point minus 4, 6. Therefore minus 4, 6 is equal to m1 into x2. m1 into x2 is 3 plus m2 x1. m2 x1. m2 into x1 is minus 6 by m1 plus m2. And y coordinate m1 y2 plus m2 y1. m1 into y2 is minus 8. m1 into minus 8 plus m2 y1. m2 into y1 is 10 by m1 plus m2. Now this is equal to 3 into m1 is 3m1 minus 6 into m2 is minus 6m2 by m1 plus m2. Minus 8 into m1 is minus 8m1. Please rectify this. Just a mistake is there. The minus 8m1, 10 into m2 is 10m2 by m1 plus m2. Now since these 2 points are equal, you can equate either the x coordinates or the y coordinates. Here in this case we equated the x coordinates. That is 3m1 minus 6m2 by m1 plus m2 is equal to minus 4. Or 3m1 minus 6m2 is equal to minus 4 into m1 plus m2 will be minus 4m1 minus 4m2. Bring all m1 terms to LHS and m2 terms to RHS. 3m1 minus 4m1 this side plus 4m1 is equal to, already minus 4m2 is there at RHS and minus 6m2 on the other side plus 6m2. Therefore 3m1 plus 4m1 is 7m1 is equal to 6 minus 4 is 2m2, or m1 divided by m2 is equal to 2 divided by 7. m1 by m2 is equal to 2 by 7. Here we have 7m1 is equal to 2m2. 7m1 means 7 into m1 is equal to 2 into m2. Here these two are multiplying at LHS and these two are multiplying at RHS. If you take this M2 to the other side, you should come to denominator, that is M1 by M2 is equal to 2 divided by 7. M1 by M2 is nothing but M1 is to M2 is equal to 2 by 7 is nothing but 2 is to 7. Therefore, the ratio in which the point minus 4, 6 divide the line joining AB in the ratio 2 is to 7. Thank you one and all.